dH dt is 1 over 125h times dV dt, which is known. dV dt is 1. Is that right? Is that what it was? 1? 1. So dH dt equals 1 over 125h times 1. So let's do it like that. So we're supposed to find this exactly when the height is what? Doesn't say. 810 minutes after the filling begins. So that's what we need to find. So how is h dependent upon t now? We need to know the height at time 810 minutes. Say again. Not the inflow.
I mean, not the inflow, but that's how much water.
Oh, you're saying, yeah, that is how much is in there at that moment. Yeah, 810 meters cubed is in there. That's right. That doesn't tell you the height. But if you use this, it will. Is that right? If you use the expression, you just create. It's like what we had before when you had to plug into the Pythagorean theorem at the end to get that last value, and you plug in as a cosine. Well, cosine to get the last value, so that'll work. So if we plug that into, what do we have here? Finally, 125, that's what we have. So V was 125 on 2h squared. And you know the volume at 810 minutes, that's what Carter said. It is 810 meters cubed, right? That's your volume right at 810 minutes. So 125 on 2h squared, you solve that for h, and you can plug that in and get your final answer. Phew. So, we'll divide both sides by 2 over 125. What will you get? What's the answer? What's that? What's the answer? If you divide it, both sides by 125 on 2, so 125 and 810 both have a 5 in it, but they don't have a 25 in it. So you could divide both of them by 5. Divide 810 by 5, what will you get? 1. Who's remainder of 3? Bring down the 1, you get a 6. 162. If you divide by 5, you get 162. But multiply by the 2, it's going to be 324. So you have 324 on 25. That is h squared. Is 324 a perfect square? Oh man, I hope so, because 25 is.
Yeah, it is.
What is it? 18. So we get 18 on 5 equals h. If you're doing a problem like this, and you get a little flustered, and then you see that, hey, wait a second, one of my numbers is a perfect square, and I'm solving for a perfect square, and it's a perfect square, you're probably doing it right. Right? So 18 on 5 is your h, so then you plug that down in here for the height at time 810 minutes, and then you'll have dH dt exactly when the height, exactly when time is 810 minutes is going to be 1 over 125 times 18 on 5. 5 and 125 cancel into 25, so you get 1 over 25 times 18. 25 times 18, uh-oh, Carrie's got it. Yeah.
So dV dt equals 125h times dH dt. dH dt equals 1 over 125h. Why don't they just cancel and equal 1?
What do you want to cancel?
Well, dV dt equals 125h times dH dt. If I'm reading that right.
Yeah.
And dH dt equals 1 over 125h. If you multiply them, you get 125h over 125h, which should equal 1.
So if you multiply 125h, and the dV dt is 1, right? Okay, so now you're looking at this equation, and what are you saying about it?
No, the equation for dV dt.
This one.
Yeah,
Okay.
it's 125h times dH dt.
Right.
And dH dt equals 1 over 125h.
Right, so dV dt is 1. That's
Yeah.
That is true. dV
Oh,
dV dt
okay.
is 1 the whole time. dV dt is 1.
I got it now.
Okay. So we still need 25 times 18. So if you think about how many times 4 goes into 18, that'll tell me how many hundreds you have. So how many times 4 go into 18? 4 times. Leaves the remainder 2. So it should be 450. Okay? So that's 1 over 450. So what are the units? Meters. We started with meters cubed, and the time was a minute. So meters per minute. Say again?
Yeah, that's how long it would take for it to fill.
No, that's how fast the height is changing
Yeah.
at 810 minutes.
Yeah. That was like the next question.
Oh, the next question?
Yeah. how long
Hold on a second. So first of all, this only takes care of the answer as long as 810 minutes later, you're not past the triangular wedge, right? If you're past the triangular wedge, you got a problem. Agreed?
Yeah.
So did they put us past the triangular wedge at 810 minutes or not? Well, it's changing at 1 over 450 meters per minute, and it's been going on for 800 and, well, that's at that moment though. Right at that moment. Ooh. So what was the height? What do we plug in for height? Was it 18 over 5? So is 18 over 5 bigger than 9? Oh, sorry, bigger than 8, sorry. Once it goes past 8, you're into the rectangular slab. Is 18 over 5 bigger than 8? Clearly not. So you were within the triangular slab the entire time. And the fact that this was here, right, that this rectangular slab was on top, doesn't affect the problem so far. All right.
Are you going to plug it into
That's a lot.
One, was it 450?
the other one?
Nice work.
How long will it take for
How long will it take to fill that stinking pool?
stinking pool?
How long will it take?
2,000 minutes.
Yeah, it took 2,000.
Huh?
2,000.
How do you know 2,000?
I just guessed it.
It's a guess.
It's a guess.
It's an educated guess based on many bad experiences.
Yep.
Yeah.
Oh, I see.
Just
I mean,
type
I
it
just
in
have a
already.
Hold on. This problem's
I have a quote.
this problem's easier than you think. The second part is much easier than the first part.
It's
It
like
has
a-
nothing to do with derivatives, basically.
Yep.
No, see, the thing is, I have a quote exactly that size.
Oh, do you?
Me,
And you've talked to the pool man quite a few times, right?
Yeah.
The second part of the problem is vastly easier than the first part. Why? Because you want to know how long it takes you to fill the thing up all the way. You're not concerned about any point along the way. It has a fixed volume. And it's entering at a fixed rate. So it's just whatever the volume is. Okay. So what's the volume of the whole pool? That's all you need to find out, basically. No derivative mumbo jumbo. So what's the volume of the pool? How do you know it's 2,000 volume for the pool?
Like I said, I have a quote exactly.
So the pool is 8 by 20, sorry, 8 by 50 by 20, 8 by 50